Students, let's look at this question here, which is on graphing techniques. Let's see how I can do this proficiently. This was taken from the year 2007 SAJC paper 1 question 7. Let's see how I can do this. So show that if the curve C has no stationary point, then negative A has to be this expression here. I think that's pretty okay. So if the curve has this equation, it doesn't have no stationary point, which just means that here you can either use dy dx or can just use discriminant. We'll see how, or maybe use dy dx. Okay, I'll just use dy dx then. So y is equals to so this part here will be x minus ax squared plus 2x minus 1. So what we get is actually v squared. So I'm just going to dy dx. This case here will be x minus 1 squared v dy dx, which is 2xa plus u minus of u dv dx. Okay, so this is done. Then after which what we're going to do is actually just put it as 2ax squared minus 2ax. Okay, so if there's no this is ax squared x minus 1 squared. So if there's no stationary point, what we need to do is actually just, we know that dy dx equals to 0. Meaning this one just means that dy dx cannot be equal to 0, meaning dy dx equals to 0 has no real roots. Okay, so you can't happen, it can't. So this case here, what we're going to do is actually when dy dx equals to 0, we know that the numerator will be 0. Then what we go is actually b squared minus 4ac is less than 0. This is minus 2a squared minus 4a c, which is negative 2 less than 0. And that will be 4a squared minus plus 8a equal less than 0. So 4a, a plus 2 less than 0. And after which what we're going to get is actually just smiley face. A, 0, and negative 2. So it has to be here. Okay, so in this case here, there you go, we get the answer. So hence A is between minus 2 or 0. That's how you show the first part. So the second part, sketch the curve A equals to 1. So when A equals to 1, I think it's pretty okay. Coordinates of any axis, okay. So A is 1, what we do is when A is 1, y is equals to x squared plus 2 over x minus 1. I'll just do a long division. So I'm just going to quickly do it. X minus 1, x squared plus 2, x squared minus x. This will just be x plus 2. So this will just be 3. So y is equals to, okay, so we know that this is actually our what do you call it? This is actually our oblique asymptote, which is y equals to x plus 1. Then our vertical asymptote will just be x equals to 1. It's pretty okay. So when you key in calculator, just make sure that you key in you usually just advise you students to just key this in, and afterwards just check and plot in your oblique asymptote there. So I'm going to just put this as let's look at that. This part here. So it will be x squared plus 2, is it plus 2, x minus 1, and oh, the wrong one that I did. So x squared x minus 1, then this oblique asymptote will be x plus 1, and we just graph it. Okay, so you get this graph here. Obviously do zoom standard first and you get this graph. So remember, if you want to change this, you could change it to like that. So it looks nicer. There's this line in this portion here, which is like what do you call it? I'm just gonna zoom it so that I get a nice curve there. Maybe not. This would be -10 and 10. There you go. Great. Yeah. So for the third one, verify that this line here passes through 1 and 2. I think this is pretty okay. To verify it, what we need to do is actually just because 1 and 2, right? So sub x equals to 1 into right hand side of y equals to k, x minus 1 plus 2. Alright, then basically right hand side will just be k, 1 minus 1 plus 2, which is actually equals to 2, which is equals to y. So hence x y, which is equals to right hand side, okay? So left hand side, no, equals to left hand side. So this is the same as left hand side. Okay, so verify. That's how we do it. Okay, let's look at the subsequent. The second part is by considering the equation of appropriate line drawn to the curve C, find the range of k for which this has no real roots. So this equation here, what we have is x squared. So this is x squared, part 4, right? This is x squared plus 2 equals to k, x minus 1 squared plus 2x minus 1. What we need to do is actually just try and find out how do we get the curve C here. This is that you sketch, which is 1, right? I'm going to just divide both sides by, very simply, divide both sides x minus 1. And then this will just be x squared plus 2 over x minus 1. This is k, x minus 1 plus 2. Okay, so you realize that actually this is your curve C, and this is a straight line. Straight line with gradient k, and passes through 1, 2, which is what you need to know, 1 and 2 here, which is what we are told to show here. Okay, now if you think about it, it's actually this point here, 1, 2 is here, the intersection between these two curves. So you need to imagine there's a line here, which is actually y equals to k x minus 1 plus 2. Okay, so this case here is pretty okay. You k x plus 2, yeah. So then what we need to do is actually just find out. So this line actually pivots about this point here. Okay, so if you see carefully, this is what's going on. I'm going to use decimals, and you can see that. Hold on. Okay, you need to visualize this. So this point here is important. This is 1, 2. I'm going to label this 2 up. And you are told that actually what happens is there's a line y equals to k x minus 1 plus 2. And if you use this slider here, just take note that with a different value of k here, so I'm going to take this out. Okay, so obviously the steeper it is, it pivots about 1 and 2. So once you do this, you can be lesser or more. So the question now wants us to have no real roots. So just take note, this line here, anything lesser than this is where the gradient is 1, right? Anything lesser than this is m less than 1. Anything more than that is m bigger than 1. Let's take note of that. So once we're done, we can, from graph, hence, for line to intersect, to not intersect C, curve C, we just want the line to be less steep than m equals to 1, right? So basically we want it to be like lesser here. This is, you have 2 equations, 2 roots, and then here no, it doesn't cut, and here, right? So this is equals to 1. So the answer should be k less than equals to 1. Okay, that's how you do this question here proficiently. Now if you have any question at all, please let me know, and I'll see you in the next question.